Hello guys, today we will make a simple program that will add two unsigned numbers. Okay, so what do we mean by unsigned? Let's find out. Okay, let me delete these comments here. Okay, so I could write my own comments here. Okay, so what are unsigned numbers? Okay, it is basically 4 minus 2. Okay, anything that results in unsigned number. Okay, with no negative sign. Okay, what if I do 4 minus 6? It results in a negative number. This is actually signed addition, signed subtraction. Okay, so we will cover this later. First we will cover simple subtraction that just do unsigned subtraction. Okay, so first we write our code here. We move 4 into x. Okay, you should have remembered these commands. Okay, you should be familiar with these by now. Okay, move 2 into bx. Okay, so now we have 4 in ax and 2 in bx. Okay, we simply subtract them, x and bx. Okay, and then HIT to halt our program. Okay, easily. So what this does is it actually do 4 minus 2 and store the results in x. Okay, so our end result will be 2 here. Okay, and remember this is unsigned subtraction. Okay, emulate. Okay, and now single step, you see 4 here, 4 is moved here. After next instruction 2 has moved into bx, and after the third instruction we get 2 into ax. Okay, which is exactly what we wanted. Okay, and this is our halt instruction. Okay, so let's write this program into MTS-86C. Okay, so okay, same 3 steps. Okay, first put your values into registers. So ax gets 4. I'm taking these simple values because these actually are hexadecimal values. Okay, so if I go above 10, this will be a b c d a, so it will get a little bit complicated. So I want you just to get the concept. Okay, and then you can try those fancy things yourself. Okay, if I basically do that, you won't be able to understand the simple concept. Okay, so we move 0 2. Okay, so we have successfully put 2 values into these registers. Okay, we don't need cx, so we leave it. We go back using this dot. Okay, and now we write our code using examine byte, or second step. Okay, we go to 100 byte. Okay, we use 100 here because when we write our program, you see we put 100 edge here. Okay, so it basically means start from 100th address. Okay, so basically it's same here. We start from 100. Okay, you can start from any place you want, but I think stick to this. Okay, it's more better. Okay, so so we write our instruction here, which is you see B8. Okay, B8 04 all the way up to F4, which is our halt instruction. Okay, so I write them in exact same order. Okay, B8. Okay, and now 04, then 00, which is already there, then BB, which is already there, then 02. Okay, 02. Sometimes values are already there because you have read in previous programs. Okay, their value remains in the memory. Okay, so then we go to the next instruction. Okay, which was 00. Oh, actually I forgot. Let's just recheck. Okay, you could go back, examine byte. Okay, from the 100. So B8. Okay, you could go back. Okay, if you forgot like I did, you could go back and always recheck. Okay, 04 00. I'm actually verifying this from emu8086. Okay, then BB. Okay, 02 00, and now there 2B. Okay, and our next instruction is C3. And finally our last instruction, which is F4. Okay, now we go back and execute our program. So we go to simulation. Okay, ST, segment offset data. From the 100 location we execute our program all the way up to F4. After this instruction our program is executed, and if we go back to examine register and we check AX, you see we get 2, which is exactly what we wanted. 4 minus 2 equal to 2. Okay guys, that's it for today. You see 2 here. Okay, we get the same result. Okay, so that's it for today guys. I'll see you next time.